Hey there, I'm Jadrian, and in this video I'm going to talk about speed, velocity and acceleration. And before we get started, I just want to let you guys know that I'm using this physics course book to teach this chapter. So in this video, I'm going to use this card to represent the speed, velocity and acceleration so that you could have a better idea of what I'm trying to say, okay? What I'm trying to explain. So first, we know that the formula of speed is speed equals distance over time, okay, which means is to measure the distance traveled per unit time. Okay, so more speed means you are going faster, right? So more speed means you travel greater distance but lesser time. Okay, so let's say we traveled a distance of 10 meters, okay, in 2 seconds. So the speed is going to be 10 divided by 2 is going to be 5 ms. So this line here is actually a fraction. It's over something, something over something. So in this case, it's going to be 5 meters over 1 second, which we do not write the 1, we only write like this, okay? This S represents 1 second. So this is the final answer. Let me just erase this first, okay? So the next one, velocity. Okay, so speed and velocity, it's actually the same. It's just that speed is scalar quantity. So scalar, and for velocity, it's actually speed. It's just that we have direction in velocity. So this velocity, it's vector quantity. Okay, so scalar quantity, it has only magnitude. Okay, magnitude is basically the quantity, the thing that you are having, but you do not have a direction for it. So in this vector quantity, we have magnitude as well, but at the same time we have direction as well. Okay, so this velocity, let's say the velocity it's equals to 5 ms. So this car right here is traveled in 5 ms, which is the speed of 5 ms, okay, 5 meters per second. So in this, so let's say to our right hand side, we will put a plus here, okay? So if this car is going to reverse, at the same speed, 5 meters per second, 5 meters per second, okay, but we will put a minus sign here, okay? So normally we do not put this plus, we just put it like this. Actually, we have a plus sign here. It's just that it is invincible, we can't see, okay, but we will know this is going to be plus, okay? So this is velocity, it has direction in it, it has plus or minus, okay? So that's it for speed and velocity, and right now I'm going to talk about acceleration. So the formula of acceleration, let me just put this aside first, and I'm going to draw a line here, okay? So right now I'm going to talk about acceleration. I'm going to use black pen. Acceleration, okay, and I'm going to erase this first. And by the way, for the velocity, you can also put this as minus 5 ms, okay? For the velocity, you can put negative 5 ms, okay? And here you can put 5 ms as well. It depends. If you want to put here the plus sign, then here you must put the minus sign. But for me, I will always put a negative sign behind here, okay? I will always put a negative sign for the reversing of the car. The car is trying to reverse, and I will always put a plus sign that the direction I'm going to travel in, okay? So let me just erase this first. Okay, just remember that the speed and the velocity, it's the same. It's just that the velocity, it has direction, okay? It has both magnitude and direction, and for the speed, it has magnitude as well, okay? So for this acceleration guy, for this one, we know that the formula of acceleration, it's acceleration equals v minus u over t, okay? So the v is basically the final velocity, okay? For the v here, it's the final velocity. Okay, I'm just going to put a v here, and for the u, it's initial velocity. Okay, for the v, it's going to be the initial velocity. Okay, I'm just going to put it nicely. Hold on. Okay, I'm going to put here. Okay, so let's say this car then travel to this north south east, travel to east. Okay, I will put this direction as our east. Okay, east, which means east is here, because north, south, east, west, right? So this will be our west. So right now our car is traveling to east. The speed of our car is 5 ms, and our car is traveling faster and faster. So slowly it will become 6 meters per second, and slowly it will become 7 meters per second. Okay, so to find our acceleration, which means a thing that is traveling faster and faster and faster, which means you are increasing your velocity over time. So every second you are increasing your velocity. So in this case right here, let's say this car is from the speed of 0, which means in the still motion, and slowly become 1, 2, 3, and 4, and 5, 7 meters per second. Okay, so our initial speed is 0 ms, right? So right now, let's say total of 10 seconds. Okay, total of 10 seconds. So our final velocity is going to be 7 ms, right? So 7 minus initial is going to be our 0 velocity over the time, which is going to be 10. Okay, so 7 minus 0, it's 7, and over 10, so 7 divided by 10 is going to be 0.7. okay, 0.7 ms squared. Okay, the reason our SI unit for this acceleration, it is because when we 7 minus 0, it is the speed, right? So the meters per second, so ms minus ms, we will still get ms, right? So and over the time is going to be second. So this s is going to times this, so s times s is going to be square, so ms square. So that is why we measure in ms square. Okay, so it's same as a over b divide c over d. So in this case, it is going to be 7, right? 7 ms over 10 seconds. So actually this is 7 meters over 1 second over 10 seconds. Okay, so right here, a times b, right? So if you want to change, we always change the divide sign into the time signs. So a over b times, we have to flip it, right? D over c. So a times d and b times c right here. So in this case, it is 7 meters set. So it is 7 meters over 1 second divide by 10 seconds, which is 10 over 1 here. Okay, so we always flip it when we see a divide sign. So if you want to flip it, this is going to be 7 meters over 1 second times 1 over 10s, which is the second. See, I flip it and just times it in, and you will get 7m. And notice here, 1 second times 10 second, it is going to be 10 second square. Okay, so 10 second square, if we divide by this guy here, 7 over 10, 0.7, and put a line here over s square. Okay, so here, so see, it is the same. So this is how we get the ms square. Okay, so I'm just going to erase this first. Okay, so 0.7 ms square which means this car every second it will increase by 0.7 meter per second. Okay, 0.7 ms. Okay, and furthermore, notice that there is no negative sign, the minus sign. Okay, which means this car it is accelerating in our east direction. Okay, but what happens that our car is reversing? Okay, let's say our car it is reversing in the same speed but different direction. Our negative sign slowly 6 ms, negative 6 ms, and slowly become negative 7 ms. Okay, the answer will still be the same. Okay, the answer it will still be the same, and in 10 seconds. Okay, 10 seconds. So let's say our car it is reversing 10 seconds and our final speed it is 7 ms. Okay, 7 ms, negative 7 ms, because it is velocity, so that means it has direction in it. Okay, so our final speed right here, it is going to be bracket negative 7 close bracket minus our initial is going to be 0, right? Because we are reversing from the speed 0 speed to negative 7 ms, or negative meters per second. Okay, so 0, the time it is the total time taken, it is going to be 10 seconds. So the answer it will still be the same. So negative 7 minus 0, it is still going to be negative 7 over 10. We will get negative 0.7 ms squared. Okay, so our acceleration is in this negative sign, which means our car it is still accelerating. It's just that different direction. Okay, our car is basically accelerating in this east direction, but we can still have a negative acceleration, which means it is accelerating in our west direction. Okay, so this is going to be minus, this is going to be plus. Okay, so if we are talking about, let me just erase this first. Okay, so let me just erase this velocity guy first. Erase here first. Okay, because I need more space to explain it. So if our car it is accelerating to our east direction, we can still have negative 0.7 meters squared, which means it is still accelerating. It's just that a different direction. Okay, it is going to be our west direction. But if you do not want to put the negative sign, we can't say that it is accelerating in 0.7 ms squared to the east, right? But the opposite of acceleration is deceleration. Okay, or some people call it as retardation. Okay, it is basically the same thing, but it is opposite to this acceleration. Let's say, okay, let's not talk about this car right now. If you are traveling acceleration, if your acceleration it is plus sign, and let's say our east is going to be our plus, our west is going to be our minus, because different direction, different sign, which means you are accelerating to our east. Okay, this is our west. But if you have a negative acceleration, which means it is still accelerating but to the west side. Okay, which means you are still accelerating but in the different direction. Okay, so what happens if we change this to deceleration? So it is the opposite, right? Okay, so right now this is our plus acceleration, right? If we talk about deceleration, we'll put negative d like this, okay, to our east. If you want to talk about the deceleration, to make this into plus sign, because it is the opposite of the acceleration. And by the way, the acceleration, it is vector quantity, okay, which means it has both magnitude and the direction. So just remember that the opposite of the acceleration, it is deceleration, okay? So right now, there are few terms for the acceleration in physics, which is, so if the course book it is talking about uniform acceleration, which means it is same, constant. Uniform means same, okay? And for non-uniform acceleration means not same, okay? It is basically the opposite thing, okay? So if in a graph, so right here, it is the speed time graph, right? So the speed time, okay? So if your acceleration it is constant, means your gradient it will be the same, because in speed time graph the gradient is equals to acceleration, okay? Means this is going to be constant acceleration. But if you see a graph like this, okay, or like this, okay, let me just use blue pen, or a curved line like this, both of these are not uniform, means non-uniform, and non-uniform. So for this straight line graph, the acceleration will be the same for this graph, and for this non-uniform graph, it will be a curved line. It's either you will curve it upwards or you will curve it downwards, but both are non-uniform acceleration, okay? Means non-uniform gradient, okay? So that's it for this video. I hope you have understood what I had just explained. And if you do not know what a speed time graph is, I had previously made a speed time graph video and I really recommend you to watch that video, okay? So that's it for this video and I will see you in the next one. Bye!